All of us have experienced projects that keep dragging on. They're never done, everyone is stressed, timelines are getting extended all the time, and so on. Sometimes they're cancelled, sometimes it leads to a bad feeling in the team after the project is done, and so on. How do we prevent this from happening? How do we de risk projects? Here are some tips. The first tip is to be clear about the goals. Who are the target audience? What features are we launching? Why are we launching these? Right? For example, if you're making a camera app, are you making it for uh, professional users or for everyone? If you're not clear about the goals, the project will be a moving target which you will never be able to hit. The next step is to avoid scope creep, right? Because everyone has a desire to add more to the project. People say, I want this, right? It's temptation. It's no different from if you're looking for a car. You want all the features, right? You want an automatic transmission. You want ventilated seats. You want everything, right? Why not? It's tempting. Unfortunately, many stakeholders don't understand the implication of their requests. So we have to say no. Certainly, the project manager or the CTO, whoever is running the project. And sometimes when we say no, people tend to get attached to their favorite request and keep saying, I want it, I want it, I want it. But we should still say no anyway. Otherwise, things will drag on. The next tip is to have a lot of small milestones rather than a few big milestones. Right? You should launch every day. You should launch continuously, which means multiple times a day. Whenever a commit is made, it goes live. If not, continuous deployment or continuous delivery, at least launch once a week. Otherwise, there's greater chance of things going wrong. Timelines are more likely to be, you're less likely to meet the timelines if you have a huge release because there's more potential for things to go wrong and so on. Build a UX prototype. I made another video about it which I'll link, and validate with users before writing a single line of code. One common source of risk is building things that people don't want. Build an engineering prototype to test feasibility. You don't want to learn 6 months into the project that it isn't feasible. Or if a modification has to be made, you want to flag that right in the beginning. The next step is to prioritize and decouple features. If you say release 3 will have 4 features, you have coupled them together. When one of them gets delayed, the entire release will get delayed. Don't do that. Let each of them go live when it is ready. The metaphor you should have is a metro station. If you are late and you miss the train doesn't wait for you, it goes ahead. You take the next train. Similarly, let each thing go out as it is ready. You should also prioritize features. And people hate this, stakeholders, they'll try to argue any way they can. They'll say, can't you do it all? Well, you can do it all, given enough time. In a limited amount of time, you can't do it all. So which do you want first? Force people to make these decisions. It's okay, right? Sometimes people have a simplistic mental model where they think if something is lower priority, it will never get done. They want to put everything in the highest priority bucket, but that is not prioritization. If you have 5 top priority things, that's a joke. It means you don't know how to prioritize. Prioritization means something has to come lower, which is good because the higher priority things get launched first. Have buffers rather than rigid plans. So, for example, if something has to be done in a quarter, get it done early. I have seen some PMs when there's 3 months and there's a feature that cram more into it. Can you do this also? Can you do this also? And then it becomes 4 months. So don't pack things tightly. Things will go wrong. You need to have buffers. So for example, saying a release has to have 3 features is a tight packing. Saying each of them will go live when it is ready is a kind of a buffer, right? Because just as ships have watertight compartments where if one compartment gets flooded, the entire ship doesn't sink, you need to have buffers in your planning where, for example, if an engineer has is expected to work 8 hours a day, well, there's company overhead, meetings, interviewing candidates, all kinds of stuff. So maybe 6 hours a day of work. So that's a buffer. And then in a week, if a person is working 6 hours a day, that is 30 hours. So don't schedule 30 hours of work, schedule maybe 25 hours of work if you really want it to be done on time. So have buffers at multiple levels, don't have rigid plans. Should be like a bunch of dominoes where if you push one, the next one falls and the next one, and the whole thing falls over. The next step is to launch and iterate. Don't hold off launching. If you launch, you will get feedback that will guide what to do next. And until it has launched, you are living in a dream world. And there's a tendency to keep adding more and more and more to the project, delaying launch further and further. Once there's this beautiful saying, no plan survives contact with the enemy, in this case with the user. So launch, get feedback. Maybe the fourth thing that you have planned is actually the most important thing to users. You can do that first if you launch and get feedback. The next tip is not to have unreasonable time pressure. Business people sometimes say this has to launch by Monday, whatever it takes. Don't do that. People will cut corners, it will cause double work and risk the project. These will cause outages, delays later on, and so on. Control technical debt. Always do work in a sustainable manner. By technical debt, you need to strike a balance, right? Some of us who have worked at the best companies in the world like Google can over-engineer things at times. On the other hand, most startups under-engineer. They don't give a shit about tech debt. So don't go to either extreme. And if you're listening to this, it's more likely that you need better engineering practices than that you need fewer engineering practices. In other words, it's more likely that your code quality is too low than that it is too high. So control technical debt. Work in an agile manner. I made a video about agile which I link. Agile means a fast reaction instead of trying to foresee the future. Don't make 5-year plans. Reality doesn't work according to your plans. Be adaptable, not rigid. The next tip to reduce risk in a project is to have a bus factor greater than 1. Bus factor is how many people in the team have to be run over by a bus before the project grinds to a halt. So don't have only one package engineer, for example. The next tip is to hire before you need. Assuming that you are sure about the need, hire ahead of time. It takes a year to hire, couple of quarters to hire, then he'll join, then couple of quarters to ramp up. So hire before you need. I'm not saying hire for positions you may or may not need. Like if you don't know whether you need a machine learning engineer, I'm not saying you should go and hire one just in case. I'm saying if you know you need one, hire ahead of time. Don't put it off till the last minute. In general, some things have a lead time and you should plan and start ahead of time. If I have a flight at 4 p.m., I need to start from home at 1, 2 p.m., something like that, right? If you don't do that, you do it in the last minute and it doesn't work. It takes more time. To continue with the airport analogy, you will drive at 200 kilometers per hour trying to reach the airport and get into an accident. So I'll give you an example. One company I know delayed hiring till the last minute and they needed people urgently. Then they had walk-in interviews. And because they did not screen people ahead of the interview, they wasted a lot of time dealing with useless candidates and they did not achieve their outcome. So some things need to be done ahead of time. If you do it in the last minute, it won't work out. You need to understand how much lead time each of them takes. For example, I told you how much lead time hiring takes. If your system has architectural problems, you can't fix them when needed. So for example, I know a company that was not able to make commitments to customers or made and violated them without fail because they didn't have good architecture, good technology. That is not something you can fix on the spot. If there's a client meeting on Tuesday, you can't fix that on Monday and then make a commitment to the client. You have to do that quarters ahead of time. So learn how much time each of them takes and start ahead. The next tip is to be patient. Sometimes founders get impatient, we get frustrated. We are like, it's not working, somehow do something, etc. People run around like headless chicken. Some amount of patience of impatience is good, but not too much. Beyond a point, it's not constructive. It doesn't help you make better decisions. It only screws with your emotions. You feel tense, you feel under siege, you make random decisions, you make things worse rather than better. The next tip to de-risk a project is to work with great engineers. Sometimes founders say, hey, we don't need like really good engineers, it's okay, like something is enough. We are not like building Google here. That's a misconception. You need a very high level of engineering skill to deliver something that works. Otherwise, you will have outages, you will have things that are poorly architected and have to be redone completely. You will have commitments made to customers violated and so on. Work with great engineers. Engineers are the input. If you think of a company as a factory, engineers are the input and the product is the output. You can't make a good car with defective steel. Similarly, you can't make a great product with average engineers. Moving on. Have an engineering lead, not just engineers. Some non technical founders just hire a bunch of engineers. They're not good at working with them. They are not good as an engineering manager and they don't have an engineering manager. Of course, it's not going to work out. You need to have an engineering lead or at least an advisor who may not take responsibility for the outcomes, but he will coach you on what to improve. He'll tell you what you need to do better. An advisor doesn't do the work for you, he helps you do it better. Whether it is a manager or an advisor, you need to have an engineering lead unless you are one yourself. If you'd like me to work with you to de-risk your projects, there's a link in the description. Thank you.